Okay, so let's go and look at one more example from section 7.5. So this is problem 5 from the homework. And it says that the measurements of the diameters in inches of 12 randomly chosen golf balls are listed. So this is the data that you see here. At the 0.05 level of significance, is there enough evidence to reject the claim that the standard deviation of the measurements of these diameters is 0.06? Okay, and we're going to assume that the population is normally distributed. Okay, so part A asks us to write the claim mathematically and identify the null and alternative hypotheses. Okay, so here the claim is that the standard deviation of the measurements of these diameters is 0.006. Okay, it doesn't say greater than, less than, no more than, or no less than, or whatever, right? It just says is 0.06. Okay, so what that means is that we're going to have the equal to symbol in the null hypothesis, okay, and then the not equal to symbol in the alternative. Okay, so in most cases, right, the wording tells you what the symbol is in the alternative hypothesis. Although in some cases, right, the wording tells you what the symbol is in the null hypothesis. Okay, but in this case, because it says is 0.06 or 0.006, right, is means equal to. Okay, so in the null hypothesis, we have the standard deviation is equal to 0.006, which is the claim. Okay, and then in the alternative hypothesis, right, the standard deviation is not equal to 0.006. So answer choice D makes the most sense. Okay, so in this problem, we're going to identify their critical values, okay, rather than find the p-value. So that's why this problem is going to be different than the two problems we did in the previous video. Okay, so before we find the critical values, okay, so quickly I've summarized the information given in the problem. So the claim is that the standard deviation of the diameter, so let's just say of diameters, okay, so the standard deviation of the diameters of all golf balls in the population is 0.006 inches, okay, and we have the diameters of 12 randomly selected golf balls in the problem, okay. So what we're going to do eventually is open up the dataset in Statcrunch or copy it into Statcrunch. Okay, but before we do that, we are asked to find the critical values for this test. Okay, so you may notice that in the setup for the problem, right, in the null and alternative hypotheses, right, the not equal to symbol is used in the alternative hypothesis. Okay. So in this case, right, where you were asked to find the critical values of your hypothesis test, okay, which is not very many problems. This might be the only problem where you're asked to do that in all of chapter 7. Okay, so if the less than symbol is used in the alternative hypothesis, right, then the test is considered a left-tail test. Okay. Okay, if the greater than symbol is used in the alternative hypothesis, then the test is a right-tail test. Okay, and likewise, if the not equal to symbol is used in the alternative hypothesis, then it's a two-tailed test. Okay, and you really only need to worry about this, right, if you see a problem like what we're doing now, right, where it asks you to find their critical values. Okay. Okay, so the not equal to symbol is present in the alternative hypothesis, so this is clearly a two-tailed test. Okay, so to find the critical values, what we need to do is take the significance level, which is 0.05, and divide it by 2. Okay, so for a two-tailed test, right, if you're asked to find the critical values, right, take your significance level, right, whatever it is. In this case, it's 0.05 divided by 2. Okay, we see 0.025. Okay. All right, what we're now going to do is go to Statcrunch. Okay, so we're going to use the chi-squared distribution calculator and Statcrunch. So we'll go to the Stat menu, calculators, chi-square. Right, so whenever we construct confidence intervals for a standard deviation or variance, or we perform hypothesis tests for the standard deviation or variance, right? We use what's called the chi-square distribution. Okay, so we want the critical values. So I mentioned earlier that you divide the significance level by 2. Okay, that may or may not be necessary, depending on how you use this calculator to get the critical values. Okay, but let's go ahead and select between. Okay, so it did say our sample size was 12. Okay, so the degrees of freedom would be 12 minus 1, which is 11. So the degrees of freedom, which goes in the top box here, is 11. So it's always equal to the sample size minus 1. Okay. Okay, so then what do we put in this box, right? So we want the left and right critical values, okay, for a 0.05 level of significance. Okay, so what that means is that the area between the two critical values, right, is 1 minus 0.5. So this might be a little confusing, so I apologize, but basically let's do 1 minus the significance level. So let's forget about dividing the significance level by 2. Okay, let's kind of forget about that for now. Okay, but let's do 1 minus the significance level, right, whatever it might be. In this case, the significance level is 0.05, so 1 minus 0.05 is 0.95. Okay, so selecting the between option for the chi-square calculator from the stat menu, okay, with the appropriate degrees of freedom, in this case 11, right, we're gonna put 1 minus the significance level in this box, right, which is equal to 0.95. Okay, 0.95. All right, we're gonna hit compute. Okay, what should happen is that it should give you two different values, right? So a value here, and then a value here. So if you do this appropriately, right, this value here will be the left-hand critical value, okay, for a two-tailed test, and then this value here will be the right-hand critical value. Okay, so for a two-tailed test, for a hypothesis test, right, there will always be two critical values. Okay, and again, you only worry about this when the problem asks for the critical values. Okay. Okay, so we're going to round the critical values to 3 decimal places. So the left-hand critical value to 3 decimal places would be 3.816. So that 5 gets rounded up to a 6. So 3.816. Okay, would be that critical value. Again, the first one, so 3.816. Okay, and then the other one is only 2 decimal places, so we're going to enter it exactly as we see it, so 2.192, or 21.92. Okay, and those are the critical values. And then it says identify the rejection regions. Okay, so for a two-tailed test, there are 2 rejection regions, right? One in the left tail, one in the right tail. Okay, so the first rejection region, okay, is going to be to the left of 3.186, and then the other rejection region is going to be to the right of 21.92. Okay, so you're going to select the appropriate graph, okay, with 2 rejection regions, right, one in the left tail, one in the right tail. So it looks like answer choice C. Okay. Okay, and now we're going to get the standardized test statistics. So this is where you're going to copy the given data into Statcrunch. Right, because the test statistic for every hypothesis test is always dependent on the data if you're given any data in the problem. Okay, or if you're not given data, it's dependent on the summary statistics. Okay, for whatever hypothesis test you're doing. So we're going to go ahead and copy the data. Okay, then find an empty column. Okay, I'm going to rename the column as diameters, since these are the diameters of golf balls. Okay, so then after finding the critical values, we're going to go ahead and go to the stat menu again, and then go to Variance Stats. Okay, we have one sample of data, so we're going to select one sample with the data. Okay, and then select the column that contains the data. Okay, so remember in the problem it said that the hypothesized value of the standard deviation was 0.006 inches. Okay. So since we have the data, we don't have to worry about calculating the sample standard deviation or the standard deviation of the sample. We don't need to worry about that. Okay, Statcrunch will do that automatically. Okay, so once we've inputted the data, okay, Statcrunch will automatically get the corresponding sample statistic. In this case, since we're doing a hypothesis test on the standard deviation, it'll automatically calculate the sample standard deviation. Okay, so what we need to enter is the hypothesized value of the variance, okay, sigma squared, Okay, so you got to be careful about this, right? So the hypothesized value of the standard deviation was 0.006. Okay, so what we're literally going to put in here is the variance. Oops. Okay, so 0.006 squared. Okay, or you can put it in your calculator, 0.006 to the second power. Okay, and then you can enter that number for the variance, right? This is for the variance, right? Or literally type in 0.006 to the second power. Okay, so to access that function there, hit the Shift 6 button. Okay, and we're going to click Compute. Okay, the other stuff is optional. Okay, so the sample variance is this number here. It's very, very small. The degrees of freedom, which is the sample size -1, so 12 minus 1 is our degrees of freedom. Okay, and our chi-square stat, or the standardized value of the test statistic, is 2.0625. Okay, we may need to round that. Okay, so the 3 decimal places, so 2.062, so that 2 gets rounded up to a 3, so 2.063. Okay, so in part D, we're going to decide whether to reject or fail to reject the null hypothesis. Okay, so normally we would get the p-value, and they compare the p-value to the significance level. Okay, that's normally what we would do. Okay, but because this problem is asking us to find the critical values of the test, okay, and then identify the rejection regions of the test, or rejection region, okay, and calculate the test statistic, right? We're gonna compare the test statistic, the value of this test statistic, to the critical values. Okay. Okay, so 2.063, right? If it's either less than the lower critical value, okay, or greater than the upper critical value for a two-tailed test, right, then we would reject the null hypothesis. Okay, but if our test statistic is between the two critical values for this two-tailed test, right, we would fail to reject. So the idea is, right, if your test statistic is in the rejection region, right, whether you have one rejection region or two rejection regions, okay, right, if it's in the rejection region, you reject the null hypothesis. Okay, if it's not in the rejection region, right, for whatever test you're doing, then you don't reject the null hypothesis. So clearly 2.063 is smaller than the lower critical value, right, so we would reject the null hypothesis. Okay, so this test statistic falls in the left tail of our rejection region. Okay, so we would reject the null hypothesis, meaning the test statistic is in the rejection region. So read these answer choices carefully, select the best answer. So answer choice A is the best answer. Okay, and then lastly, we're going to interpret the results. Okay, so we've already determined that we rejected the null hypothesis because the test statistic is in the rejection region. Okay, so remember. Okay, the problem, the claim was that the standard deviation of the diameters of these golf balls is equal to 0.006 inches. That was the claim. Okay, and according to our test here, we are rejecting the null hypothesis, right? So we are rejecting that claim. Okay, so in other words, right, there is not enough evidence to support the claim that the standard deviation of the diameter of these golf balls is 0.006 inches. Okay, so we're going to select our answer based on that conclusion. Okay, so the question is, right, is there enough evidence to reject the claim at the 5% level of significance? Okay. And the answer is yes. Right, since the null hypothesis is rejected, there's enough evidence to reject the claim. So it looks like answer choice B, but read this carefully on your own. Okay, we've correctly completed question 5. Okay, so hopefully you won't see a lot of problems like this one, right, where it's asking you to find the critical values, identify the rejection region, then calculate the test statistic. Okay, that's actually a little more difficult than calculating the p-value. Okay, but in any case, right, you always look at the symbol used in the null hypothesis to identify the type of test, right, whether it's a left-tail test, right-tail test, or two-tail test. So again, the symbol used in the alternative hypothesis, not the null hypothesis, but the alternative hypothesis, right, determines the type of test. Okay, which is then where the rejection region is.